Dear students, in the previous class we have discussed up to the diffusion of chapter 2. Today also we will discuss chapter 2. The name of the chapter is States of Matter. So from this chapter, how to find out the molecular mass is molecular mass of ammonia gas. Okay, everybody see that the atomic mass of nitrogen, atomic mass of nitrogen equal 14 and hydrogen equal 1. Now, so it will be 14 plus 1 into 3, that means 17. Okay, now molecular mass of hydrogen chloride gas. Here also atomic mass of hydrogen is 1, atomic mass of chlorine equal 35.5 and hydrogen equal 1. Now if we add the atomic mass, then we will get the molecular mass. Here we see that molecular mass of ammonia gas is 17. Okay, now we will find out the molecular mass of hydrochloric acid or hydrogen chloride gas. So hydrogen it is 1 plus chlorine it is 35.5. If we add, then we will get the molecular mass of hydrogen chloride gas, that means it is 36.5. So we know that a gas with lesser molecular mass will have the higher rate of diffusion. A gas with lesser molecular mass will have the higher rate of diffusion. Therefore, the diffusion rate of these two gases, that means the diffusion rate, therefore the diffusion rate of two gases will be ammonia gas greater than hydrogen chloride gas. That means the molecular mass of ammonia gas is 17 and the molecular mass of hydrogen chloride gas is 36.5. So we see that a gas with lesser molecular mass will have the higher rate of diffusion. So for this reason, here ammonia gas is greater than hydrogen chloride gas in concerned diffusion rate. So ammonia gas will be diffused faster than hydrogen chloride gas. Okay. Okay, now what is effusion? The passage of gases from high pressure zone to low pressure zone through a fine pore is called effusion. Okay, everybody see that it is actually the passage of gases from high pressure zone to low pressure zone through a fine pore is called effusion. For example, if a balloon we take, if we make a fine pore, then all the air from the balloon will come out with a pressure from the high pressure zone to low pressure zone. So this is effusion. Now what is CNG? It is actually compressed natural gas. CNG, compressed natural gas, it is compressed methane gas at high pressure. Okay, now so we have seen what is effusion and what is CNG. So effusion I told. Now CNG, all of you see again, it is actually the methane gas. It is compressed natural gas. So methane gas is compressed at high pressure, then we are telling it is CNG. Now CNG is widely used in vehicles as fuel, and so first of all I have given in the previous class we have given what is diffusion. Today I have given what is effusion. So there are some differences between these two topics. First of all, diffusion, we have seen that the molecules of any medium, that means in solid, liquid or gas, that the molecules transform from high concentration to low concentration, that is diffusion. Now in case of effusion, in the gaseous system or in the gaseous condition, the molecules are passes from high pressure zone to low pressure zone, that is effusion. So for the diffusion, pressure is not required, but for the effusion, pressure is required. Then diffusion, it may occur in any media, I mean in solid, liquid and gas, but effusion, it occur only in gaseous medium. Then in the diffusion we see that molecules turns from high concentration to low concentration, but in effusion the gaseous molecules turns from high pressure to low pressure, high pressure zone to low pressure zone. These are the differences of diffusion and effusion. Okay, now everybody see that I have drawn a diagram. It is burning of wax. So if wax is burning, then what happen? You see in the diagram that there are some wax, it is melting, so this is liquid wax and this is a solid wax. So now it is burning. Now what happen? Actually wax is a different component of hydrocarbon. So what is hydrocarbon? The organic compounds made of carbon and hydrogen is called hydrocarbon. So if hydrocarbon is burned, then there is a chemical reaction occur, that is it produces carbon dioxide, water vapor and heat and light energy. So from the burning of wax we are getting light energy and heat energy, and some wax is melting. So we see that the solid wax and the melting wax, actually this is the almost same characteristics and there is no chemical change, so that is physical change. So during the burning of a wax, two types of change occur. One is physical change, another one is chemical change. So chemical change, I told that here by burning a wax, it is producing carbon dioxide, water vapor, heat and light energy. And by melting, some wax is melting, so that is the physical change. Okay, now I told also this is a hydrocarbon. So for example, methane is a hydrocarbon. If methane is burned in oxygen, then we are getting carbon dioxide, water vapor and plus heat or light energy that we are getting. Okay, so if the question is like this, when a candle is burning or burning of wax, what types of changes occur? So we will tell two types of changes occur. One is physical change, another one is chemical change. Okay, dear students, now melting. The process of transforming a solid matter into liquid by means of applying heat is called melting. Okay, now what is melting point? At normal pressure. Okay, normal pressure, that means at 1 atmospheric pressure. At normal pressure, the temperature at which a solid matter turns into liquid state is called melting point of that solid. For example, melting point of ice is 0 degree Celsius. So dear students, you please see that what is melting and what is melting point. So I have written first one is melting. The process of transforming a solid matter into liquid by means of applying heat is called melting. Then what is melting point? That at normal pressure, that means at 1 atmospheric pressure, the temperature at which a solid matter turns into liquid state is called melting point of that solid. That means I have given one example. Melting point of ice is 0 degree Celsius. Okay, dear students, now we have given the melting point and melting point. Now boiling and boiling point. Just there is a difference. All of you see that. First one is what is boiling. So the process of transforming a liquid matter into gas. by means of applying heat is called boiling. So just two word is change, liquid and gas. Okay, then what is boiling point? So at normal pressure I told, that means at 1 atmospheric pressure, the temperature at which a liquid matter turns into gaseous state is called boiling point of that liquid. Now the boiling point of water, it is liquid, is 100 degree Celsius. So see that by previous topics, this topics is very much clear and understandable. Boiling, the process of transforming a liquid matter into gas by means of applying heat, is called boiling. Then what is boiling point? At normal temperature, at normal pressure, that means at 1 atmospheric pressure, the temperature at which a liquid matter turns into gaseous state is called boiling point of that liquid. The boiling point of water is 100 degree Celsius. Okay, dear students, now I have drawn a graph. This is graph of applying heat on ice. GRAPH, graph of applying heat on ice. So all of you see that in the x-axis I have taken time, and in the y-axis I have taken the temperature. So the graph, it started from minus 40 degree Celsius temperature. So from the starting line, when it comes at the 0 degree Celsius temperature, then we are getting a line, AB line. So AB is the melting point of point line of ice. That means when the temperature is coming at 0 degree Celsius, then it starts melting. So from A to B, this is the melting point line of ice. Now this one, now it starts, it is the water BC line. When the temperature comes from B to C, that means from 0 degree to 100 degree Celsius, this is liquid condition water. Now when it is coming to the 100 degree Celsius, then it starts boiling. So CD, it is boiling point line of water. So and D, from D to upper, it is vapor, water vapor. So our topics is explain the graph of applying heat on ice. So first of all, I draw the graph starting point 40 degree minus 40 degree Celsius temperature. When the temperature is rising up by the time, then it is coming to the 0 degree Celsius temperature, then it starts melting. So this is the melting point line of ice. Then when the temperature is rising up, gradually the ice is solid. Now it is in liquid, that means water. So when the temperature, again by applying the temperature, it reaches 100 degrees Celsius, then it will starts boiling. So CD line is the boiling point line of water. Then after that, if the temperature is more than 100 degree, then the condition will be the gaseous, and that is water vapor. Okay. Okay, now dear students, you see that another graph, it is cooling. Okay, now just the opposite of the previous one. Here the from 140 degree the line started and it is coming up to minus 40 degree. So from 140, this is the vapor condition I have shown, and 100 degree this is the boiling point, and this is melting point 0 degree, and this is water. Okay, so here the temperature is 140 degree starting point. So when it is coming down, then when it comes to the 100 degree Celsius, then it starts boiling. So now the boiling point of water, that is 100 degree Celsius. Then 100 to 0 degree, this is the water condition, liquid condition. When it comes down to the 0 degree Celsius, then it is the melting point line, that means it is ice, and after the melting point this condition is ice. Then that means minus 40 degree Celsius, it is the last point. So from the graph we see that the vapor, from vapor to boiling point, then boiling point to melting point, there are three conditions. One is ice, another one is water, another one is vapor. That means solid, liquid and gas. So we have seen two graphs. One is applying heat on ice, another one is cooling curve of vapor. So from vapor to ice, and the previous one was ice to vapor. Okay, all of you please write it. Okay, dear students, now I have written what is vaporization. The process in which a liquid turns into gas by the application of heat is called vaporization. So now condensation, just the opposite, the process in which a vapor turns into liquid is called condensation. And distillation, it is equal vaporization plus condensation together. So if vaporization and condensation, this together is called distillation. Now sublimation, the process in which a solid substance directly transform into gaseous instead of a liquid state is called sublimation. Here we can give some example of sublime substances. This is ammonium chloride, NH4Cl, then camphor, then naphthalene, okay, like this. Solid carbon dioxide, camphor, it is C10H16O, and naphthalene, it is C10H8. Then solid carbon dioxide, iodine, these are the sublime substances. Okay, students, all of you see that in this page I have given first of all what is vaporization. It is the process in which liquid turns into gas, that is called vaporization. And condensation, just the opposite, the process in which vapor turns into liquid is called condensation. Now these two together, vaporization and condensation together, is called distillation. Then sublimation, the process in which solid substance directly transform into gaseous substance, just solid to gas. These substances are called sublime substance and the process is called sublimation process. So I have given some example: ammonium chloride, ammonium NH4Cl, then camphor C10H16O, then naphthalene C10H8. Then more example can be given: solid carbon dioxide, also sublime substance, then iodine. So these substances, if we apply heat directly, it will just convert to gaseous substance. For this reason, these are sublime substances and the process is called sublimation. So dear students, today from chapter 2, states of matter, I have given, first of all, I have shown the rate of diffusion. If the molecular mass is smaller, diffusion rate will be the higher. Then I have given effusion, then CNG, and differences between diffusion and effusion. Then I have given what happen if wax is burning. I told that by burning wax we see two changes: one is physical change, another one is chemical change. Then what is melting? Melting point. What is boiling? Boiling point. Then I have given the two graph. One is applying graph, heat on ice, another one is cooling curve of vapor. Then I have given what is vaporization, what is condensation, what is distillation, then what is sublimation. All of you, please, you see the video attentively and try to learn the lesson and take preparation accordingly. Okay, thank you everybody.